We're going to be making this effect using geometry nodes fields within Blender 3.0 using about 6 basic steps. So this is the file we'll be making today. This is the geometry node setup we'll be making, where each of the frames that we have here corresponds to one of the steps that I showed. If I click play, you can see that each of the legs wiggles, and if you move it around, it gives us the exact effect we're looking for. So let's make this. So let's open Blender. Let's create a cube. A circle, a cube. I'll scale this up to around 4 times the size because I want it that size. I'll go to this view to make my life easier to see the effects we're making in the starting. I'll add in a empty to work as the handle that we'd like to use. And here, go to and add a geometry nodes modifier. Now we can go to geometry nodes, go to this view where we have this thing. Yep. And now let's distribute points. So what we can do is a point distribute and put there, and there we can see that we have points everywhere. Now we need to instance a line that is within a certain distance of this empty, right? So let's instance, and then let's do a curve line, right? It's a curve line, and what we'll do is take the curve line and then put that as the instance, right? But now this is everywhere. We want it to be within a certain distance, so what we can do is take a location attribute, over here, location position, sorry, a position attribute. Take the location of this object, which is of the empty, which we can get through a object info node, and then take this. Let's rename the cube to surface. Actually, let's rename the cube to a something else. Let's rename it to surface, and let's add in some. Let's add in a what do you call? Actually, let's add in a cube called surface. Make it 4 times as big. Take this one, call it creature, and why are we doing this? Why we did this separation of surface in this thing? You'll see. Basically, if I disconnect this, right, and add in a object info node and select the surface, now the creature and the surface are 2 separate meshes, or 2 separate objects, so they're independent of each other, which gives you a lot more freedom in terms of the mesh that you like to use. So if, for example, I go to surface and click apply scale. If, for example, I go to the surface mesh, and what I do is I want to have more than one mesh, right? For example, I want to duplicate this. I select the creature mesh, I duplicate this, and I say I want this mesh. I click join geometry, and then join these two, and I click apply location, or I can just go here and click as instance or relative. Now the points exist on both of these, right? So that gives you more freedom in terms of the objects that you like to have the creature interact with. So take this. Now what you can do is do a vector math, pull that up there, and subtract, or actually distance, right? Location, again relative. So now what you can do with this, you know, the distance between the point and the object, what you should now do is do a math function less than, less than, and some threshold value. Now this is your selection. Let's say that I want the thing to be less than 3. So wherever the distance is less than equal to 3, let's move it to the edge so that we can see what's happening. Right? Whenever the thing is less than 3 in terms of distance, this geometry node setup instances a line, right? Which is cool. Let's save this on the desktop. Call it creature. Save that. Now we have this. We have lines being instanced everywhere. Now we need to align these lines to the main, to the center of this object, to this empty. What we can do is take this, duplicate this vector math, and do a subtract function, subtract math thing, and then do a align this, align vector rotation and z, because our lines point in the z direction, and plug them into the Euler. Actually, wait, plug them into rotation if I'm not wrong. Or am I tripping? I think I missed something. That's scale, my bad. Rotation. And subtract should work. Oh wait, sorry, my bad. Vector. So plug that in there, and now all of them align to the vector. Now we need to scale each of these lines with this distance. Now we know what the distance is, which is this. So all we need to do is take this distance, combine it with 1 and 1 in the x and y direction. So combine. So why are we combining it with 1 and 1 in the x and y direction? Well, because we wanted to scale it along the direction that the line is moving, but not in the direction, but not in the x and y direction as a whole. Because if we do that, then each of the legs is going to be wider than the other. That kind of causes it to look weird. So plug this in here. We have combine x, y, z, and scale it like that. Now things are aligned backwards, so let's move this here, and now each of these is aligned towards the center. Done, right? Now let's give each of these legs a shape. So what we can do is curve to mesh, plug that in there, and then a curve parameter, and then let's take a circle, a curve circle, and plug that in here. That's going to be the shape of this curve. Let's set this to 0.1. So we have a bunch of tubes pointing toward the center, but we don't want tubes. We want it to like taper off as it goes, right? So take a set radius node, put that in there. That tapers off, but it's not very aesthetically pleasing. So what we can do is take a color ramp, put that in here, then take a resample curve thing and plug that in there. Now chances are you'd want to plug in your nodes and stuff here. So let's say this is the distance that we want the threshold to be, right? Plug this in here. We want this number. This number is going to come in handy later. So I'd recommend plugging this here as well. And this number is pretty useful as well. So let's keep this at 30, and let's plug this in here as well. Done. Now, why we did this is so we can move this here, add a thing in between, or more specifically move this here, move this, make this black, make this slightly darker, and then move it here, move this here, add another, move this here. So now you can see it kind of looks like it's tapering off. Like you can see the shape of it a little better. I think there are too many legs, so I'm gonna decrease the density. I'm gonna change it to 1, or actually I'm gonna change it around 3. That's pretty good to me. So if I select that, you can see that now we have the thing. It kind of looks like it's working, right? So now what I wanted to do is I don't want it to snap. Basically, if you can see, it kind of snaps from one to the other, right? I do not want that to happen. I want it to reach towards the walls. So what I'm gonna do is first over here in the scaling thing, right? Let's move this down here, right? Right. Just move this down here, the distance node. Let's change it, right? So let's do a color ramp, right? The distance is currently from some number to the maximum, which is your threshold, right? Because after that it doesn't get instant, so we don't need to worry about those possibilities. So this number, your threshold, is the maximum. So what we're doing is basically saying math divide whatever the distance is, as in whatever the length is, by this number. So basically it scales everything to 1. Why we're doing that is basically it makes our color ramp work, right? So now take this, move it to position of 0.9 or like whatever position you want, and change the value to the same number. Then change this thing back to 0, right? Now you might think it's not working, right? But wait a second, we divided it by that number, and then to get it to map between 0 and 1, we need to again multiply to the same number, as in move this here, right? Multiply, and let's do this and move it here. Multiply and same number. Now you can probably see that it reaches from the wall to here, which is almost where we want, but we want each of these to be towards the center, right? Now the thing about instance node is once it instances these, each of these is still its own separate instance, right? The properties of each instance are still preserved, which is good for us because it lets us do a set position node, and in the offset, because remember each instance has its own separate let's say entity, because then its scale and rotation are still maintained. So if I move them by 1 and 0, right, as a whole they move, but if I go back to this node, right, and I do a, let's say, math, and let's do a subtract, right, and subtract this and this, as in basically I'm subtracting the distance, the difference between where it is and this part, right? Basically, let's take this leg for example. This leg is this distance away from the center. How do we know that? How do you know that information empirically? This part, this number here, maps to 0.9 and has at 0.9, after which it falls back to 0. So this color ramp area tells us the distance here, right? Take that and let's roughly just like plug it in here, right? You can see that only those legs which are less than the maximum like length move, right? That's great for us. Now we just need to align this to the vector here, right? So that instead of just moving all the way, they move only in this direction. So we can do two things. Either we can do this, combine XYZ, combine here, and then offset here, which moves all of them up, and that would work if we did it in a different alignment, right? Or we have the vector that shows us this alignment, right? So take this, do a vector math, and then set this to normalize plug this in here, duplicate this again, set this to multiply, plug this here, plug this here, and now ta-da, it aligns to that, right? Actually, wait, we should also probably multiply this with this thing. Yeah, there we go. Now let's go to the handle. Now it reaches forward, as you can see. There we go. Now we want it to wiggle. So this is where these two resolutions we saved earlier come in. So each leg has this resolution times this resolution number of vertices. So that's the ID of each vertex, right? So let's realize instances. So basically what it does is it removes, as you can see, if we remove this, each instance has its own thing, but once we add this realize geometry or like realize instances node, it realizes each of these instances and makes it one whole mesh and assigns a index to each object, right? That's pretty cool. But the main thing that we need to do is, let's go and take these two nodes, right? Let's add a math node first to find out the number of vertices on each leg, which is this times this. There we go. Now if we take this and do let's do another multiply. I'll show you what I'm talking about. Multiply, plug this here and do a delete geometry, right? Let's do ID here and let's do a math. Let's say less than. Plug this in here. Now basically for each ID that is less than, let's say, this thing, it will delete the geometry. Let's do actually greater than, it will make more sense. This is 0, right? If we add 1, for the first leg that appears, reappears. Really, we're not deleting that geometry, right? Then this, then the third leg, then the fourth leg, which is, you can't really see it because it's behind one of these legs over here, right? Let's do the fifth leg. Fifth one appears, right? I mean, wait, if we go back and change the distribution from random to %, I think then that should be able to help a little bit. Let's do 1. Actually, let's do 0.3. Here we go. That way the legs don't actually correspond with each other. Yeah. Anyway, so that's basically what we'll be doing. So let's take this, right? And the ID, we want to take a math node, plug this in here. We want to divide it with this. Now basically what you're doing is saying whenever for each leg, map the IDs from 0 to 1 again, right? But because for each leg they have an offset of 1, so one leg goes from 0 to 1, the next will go from 1 to 2, so on and so forth. So to map all the legs from 0 to 1, right, you take this and then you go to the fraction function. Now this takes only the fractional part of each leg, right? And then now take a color ramp, right? We don't need this delete geometry node anymore, right? What we want is an offset, set position, right? Take this and let's plug this in here, right? And To show you what I'm talking about, let's add another color here. Let's select the white one and select both sides to 0. Do you see what's happening here? If we take this to 0, I think you'll be able to kind of see what's happening. Wait, we have too many legs again, so we can reduce the density to 1, or let's say 3 is pretty good. Let's say 2 is pretty good, yeah. Right? So now the central part basically selects how much we're offsetting each thing by, each, let's say, leg by. Right? It basically forms a gradient. Now we don't want this to just be the thing because it looks kind of boring, right? And it doesn't look very great. So once this is done, what we can do is multiply as in vector math and multiply here and do a noise texture and set the roughness to 0, detail to 0, and scale it around 1 or 2 because we want it to be pretty broad strokes, and then multiply this there. Right? Now you get this. Right? What this gives you, and then let's say when you change it to 4D, and let's just put a driver, that's a driver something like this. Now this wiggles. If I want to increase the amount of wiggle, I can do this, right? But the problem is, as you can see, if I increase the wiggle, it starts moving forward because the average value of the noise texture is 0.5. So let's take a vector math, and subtract 0.5 on all sides. Now the average value of that noise texture is 0. You can see it goes pretty well. It looks pretty, what do you say? It looks pretty good, but the resolution on the lengthwise direction leaves something to be desired. So let's change it to a 3, change it to a 30. Now it's a lot more smooth and it looks a lot better. This now you can control with this handle in any direction you want, and that's how you make this venom creature looking thing.